Question number 9 from NEST 2014 based on trigonometry. A vertical lamp post is located at one corner of a level ground. The ground is in the shape of a regular hexagon. A man walks from the foot of the post to the next three corners of the ground in clockwise direction and notices that the angle of elevation of the top of the post from each of the corners are alpha, beta and gamma respectively, where alpha is greater than beta is greater than gamma. Then cot squared gamma equals cot squared beta plus cot squared alpha. Cot gamma is equal to cot alpha plus cot beta. Cot alpha cot gamma is greater than cot squared beta. Cot squared alpha plus cot squared beta plus cot squared gamma is equal to cot alpha cot beta plus cot beta cot gamma plus cot gamma cot alpha. Okay, now look, because they have clearly mentioned here that he walks from the foot to the next three corners. So we now know that he is first going to the adjacent vertex, then the next and the next. Okay, so here are the three figures that I have drawn in isometric view. Okay, so 3D view. This is the hexagonal ground, and this red segment is our lamp post. Okay, the red segment is our lamp post. Let us suppose that its height is capital H. Okay, let us suppose that the height of the lamp post is capital H, and as they have said, the angles of the elevation of the top, they are alpha, beta and gamma. So let's say he walks from O to A. Okay, then that is alpha. He looks at the top, he measures that angle, then he comes to B. Again he looks at the top and then the angle is beta. Then he comes to C and then again he looks at the top of the pole or lamp post and then he finds that the angle is gamma. And we would like to find a relation between alpha, beta and gamma, and this is a multiple choice question. So even if you get one of the options to be right, then that is the right option. Okay. Now, how are we going to solve this particular problem? See, clearly the tan ratio is at work here. Okay, tan alpha, tan beta or tan gamma, and in the options you see it's cot, so that's fine. Okay, now if you take the tan alpha, okay, tan alpha, it is the height of the lamppost upon OA. For beta it is height of the lamppost upon OB, and for gamma it is height of the lamppost upon OC. Correct? So it is essential to find out the sides here, OA, OB and OC. Okay, so our first part of the problem will involve finding these. Let us assume that the side of the hexagon is A. Okay, so it's a simple geometry problem. So let's now find OC and OB. Okay, now this is the top view. Okay, this is the top view of the ground. So O is the point where he started. Okay, and then he is going to A, then to B, then to C. Okay, so O to A, then A to B, and then B to C. Okay, okay. First, we consider triangle OAB. Okay, first we consider triangle OAB and apply cosine rule. And we know that in any regular hexagon, the angle between adjacent sides, the interior angle, is 120 degrees. So angle OAB will be 120 degrees or 2 pi by 3 radians. And because both these sides are equal to A units, as I told you here, we are going to assume that OA is A. OB squared will be, by cosine rule, OA squared plus AB squared minus 2OAAB into cos of the angle OAB. That's what I've written here. A squared plus A squared minus 2A squared cos 2 pi by 3. Cos 2 pi by 3 is negative half. 2 will go, minus will become plus. So that will effectively be A squared plus A squared plus A squared, right? Because minus into minus plus and 2 upon 2 is 1. So OB squared is equal to 3A squared, and therefore OB's length is now obtained, that is root 3. Okay, so two objectives were there. OB has now been found out. So it is no longer an unknown, it is root 3 times C. Now let us calculate OC. Now if you know the geometry, can we very easily say that OC is twice AB. But suppose you need a proof. Okay, let us drop a perpendicular from A on OC. Okay, so AC1 is perpendicular to OC. Okay, AC1 is perpendicular to OC, and because C1 AB is 90, okay, because that's parallel, again that's parallel. Angle CAB is 90 degrees. Angle OAC1 will be 30 degrees because the total angle OAB is 120. Okay, so OAC1 is now 30, 60, 90 triangle. OAC1 is now 30, 60, 90 triangle. So side opposite to 30 degrees is half of the hypotenuse. So OC1 will be A by 2. Okay, and by symmetry, if we drop a perpendicular, okay, if we drop perpendicular from B on this, okay, hexagon, then let's call it C2 now. So OC1, okay, whatever the length OC1 has, C2C will also have the same length, and C1 C2 will be AB. So OC will be OC1 plus C1 C2 plus again C2C. Both of them are A by 2 A by 2, and the central one is A, so that will give us OC as 2A. So the third objective, or the second objective, sorry, that is also complete. OC is no longer an unknown. OC is 2A. Now we know everything is, we have everything ready with us to find the cotangents of alpha, beta and gamma. So let's do that. Okay, first cot alpha, remember it is adjacent upon opposite. Usually we deal with tan, which is opposite upon adjacent, but now it is adjacent upon opposite. So for cot alpha it will be A by H. Okay, for what is there for cot beta? Cot beta is OB upon height of the pole, and cot gamma is OC upon height of the pole. OB is root 3A, OB is root 3A, OC is 2A, OB is root 3A, and OC is 2A. Okay, now look, A by H, A by H, A by H is there in all three, and if you notice, then you'll realize that 1 squared plus root 3 squared is 2 squared, right? Which means cot squared alpha, cot squared alpha plus cot squared beta is equal to cot squared gamma, right? Cot squared alpha, which will be A squared by X squared, cot squared beta will be 3A squared by X squared, so that will effectively be 4A squared by X squared, and if you take the root of that, you will get cot gamma, which is 2A by H. So correct option is A. Okay, correct option is A. Now I will leave the, well, as far as the MCQ is concerned, we are done, but I leave the part of showing BCD don't produce the correct answers to you. Okay, so that's your homework. Show that B, C and D are incorrect. Okay, show that B, C and D are incorrect. Okay, I'm sure you will be able to do that. If you face any difficulty, please comment it. I will answer those queries. So that's question number 9 from NEST 2014.